All right, so before going any further in this video, you should have already seen part one, where we talked about some fundamentals on where the basic shape of the hyperbola comes from. And so in this video, what we're going to talk about is where we kind of left off in the last video. In the last video, we talked about, what we'd have to do in order to take our parent function of our hyperbola that we derived here and basically get the same thing to be reflected, if you would, about either the x or the y-axis, however you would envision that. So how would we go about getting that to happen? All right, and that's what we see here in this graph. And then in the second graph, we discussed on, what would we have to do to the equation to get this graph to shift to the left 3 and up 1, like you see here. All right, so let's go through that. And I kind of gave you a little bit of a preview to the answer there. Because if we take a look here at what's happening in this example, what we can identify is that we do have a reflection taking place. And what we see now is actually what the graph's representing is, it's saying that if my x value is positive, my y value is negative. That's what it's telling us in quadrant 4. So if the x value is positive, the y value is negative. So if we kind of put 2 and 2 together here, this is telling us that in order to get this graph to occur, it is nothing more than just taking the reflection, or in other words, substituting a negative in as far as the constant is concerned. So now what we'd see is that if I put a positive 1 in for x, that's actually going to result in a negative 1. And on the flip side, if I substitute a negative 1 in for x, it's going to result in a positive 1. So it's good that we see these connections being made to, how graphs were manipulated previously, to how they're still manipulated, even though we're working with a whole new type of equation, this hyperbola. Now, let's go a little bit further. And what we're talking about now is not necessarily reflecting it so that way it's in the second and fourth quadrant. Now we're looking at translating it left and right and up and down. But again, therein lies the key. We're shifting to the left and we're shifting up. So if we think about this now, this is a big key right here, where it's telling us the asymptote is at x equals negative 3. So what that's basically telling me is that in my denominator, I have an x plus 3. And why is it telling me that? Well, think about the asymptote for a second. The asymptote tells us what the value is not allowed to be. So if I substitute a negative 3 into this expression, I get a 0. And I can't divide by 0, so therefore I have my asymptote there. And now I have the bottom portion of my hyperbola, which is very synonymous to what we've already done with quadratics, what we've done with radicals, and what we've done with exponentials. Whenever we have a constant value inside of the function, it translates it left or right in the opposite direction. So here's plus 3 inside of the fraction, and it's shifted at left 3. Now that's key for us because now let's think about the vertical action. How do we shift things vertically? Well, all we're doing is changing every y component in this case by a value of 1. So that manipulation will take place outside the function. So now all I did is I took every value that I was calculating it and shifted it up 1 unit by adding 1. And now we actually have our equation 1 over x plus 3 plus 1. So there's our answer to part 1 of the instructional video where we had to kind of make our own guesses. And now I'm going to give you a second chance to kind of work ahead of schedule, if you would. What I want you to do now is take everything that we learned from the 2 instructional videos and make a prediction now on the graph of negative 2 over x minus 4 minus 1. Now there's some things in here that are similar, but you have to kind of combine some concepts together that we talked about, and there is one new thing. For the very first time, yes, you got it, we actually have a value other than 1. Now we have a 2. How's that going to change our graph? Pause the video, make your prediction, and I'll work through it here in a moment. All right, so again, I'm hoping that you had a chance to go ahead and already come up with your own prediction. And whenever I'm going to graph these, I'm going to start off by identifying where my asymptotes are. Simply put, I see that I'm going to have a vertical asymptote at 4. So I got 1, 2, 3, 4. There's my vertical asymptote. And now my horizontal asymptote, I see I have at -1. You'll also see that I am labeling my asymptotes with the correct equation. And now, before I go and start plotting points, let's think about this here for a second. 4 is a value I'm not allowed to substitute in for x. So let's go ahead and think about the first value or first integer value to the right. So let's think about what would happen if we substitute 5 in for x. And I like substituting 5 in for x because 5 gives me a denominator of 1. Well, that's really easy because -2 divided by 1 is -2. -2 minus 1 gives me -3. So let's look at where that point is. That would take us to 5, -3. 1, 2, like so. And if we think about what's going to end up happening here, it's going to be synonymous to what we've done before. As I get larger x values, it's going to make this fraction smaller and smaller, which is going to approach -1. So as I go to bigger numbers, I'm going to approach -1. And as I get closer to 4 or closer to 0, I'm actually going to make a bigger number here. So it's actually going to be like so. Now, let's look at the other side. So let's just try to clean this up just a little bit. We'll pull these guys out. Whoops. That's gravity for you. Undefeated. All right, so let's go ahead and look on the other side, though, of the asymptote. So now let's actually take a look at substituting the value 3 in. Now, 3 gives me a value of -1, because 3 minus 4 is -1. -2 divided by -1 is 2. 2 minus 1 gives me 1. So now, by substituting 3 in, 2, 3, I get a value of 1, which again makes sense because now we can see that I'm actually in, according to the asymptotes, the upper left quadrant and the bottom right quadrant, which is consistent when we have a negative coefficient in our numerator. And again, what would happen is I'd get larger values as I get closer to 4, smaller values as I get bigger and bigger in the negative direction. And there's our final result.